So, we've talked a lot about solar flares and space weather, but what actually happens when all that energy hits us here at home? When the systems we depend on for literally everything just start to fail? And I'm not talking about your Wi Fi router needing a reboot. We're talking about the very real, sometimes catastrophic consequences when our electronic world gets knocked sideways. All right, so we're jumping back into this incredible technical report from the RFI detectives. This is part 9 of our 10-part deep dive, and today we're really getting into the so what of it all. We're looking at the cascading failures, the ripple effects that spread through our society when the electronics suddenly stop working. This quote from the report is pretty much the theme for today. It nails a concept that is so important to understand: the cascade. Seriously, think of it like dominoes. One tiny, seemingly insignificant electronic hiccup can kick off a chain reaction with consequences that are just way out of proportion to that first little problem. So, how does that first domino get tipped over? Well, it doesn't start with a big explosion or a flash of light. Nope. It all begins with something totally invisible, something that traveled 93 million miles from the sun just to mess with one tiny component in your device. That's exactly it. The real cause, the root of all this chaos, isn't something you can see, like a frayed wire or a power surge. It's microscopic. A single high-energy particle zips down from the sun, smacks into a processor, and right there, that's where the problem begins. It's a completely silent trigger. Okay, so the technical term for this is a single event upset, but honestly, it's way simpler than it sounds. Here's how it works. Step 1, that solar particle we talked about hits a microchip. Step 2, the impact is just enough to flip a single bit of data. A 0 becomes a 1. That's it. And then, step 3, the system, which has no idea anything is wrong, just goes ahead and executes a command based on that one little piece of bad data. It's a perfect and kind of scary example of how something microscopic creates a major malfunction. Look, if your smart TV accidentally reboots because of a bit flip, it's annoying, right? But it's not the end of the world. But what happens when that exact same event, that single bit flip, happens inside a system that we trust with our health, with our safety, maybe even with our lives? Well, the stakes get a whole lot higher. And this is exactly where the consequences go from being a minor inconvenience to a full-blown emergency. We're talking about the critical systems that run everything: our hospitals, our high-rise buildings, our core infrastructure. When those fail, the impact is immediate and it's very human. The report lays out some pretty chilling examples. I mean, just imagine this. A hospital's infusion pump, hit by one of these particles, suddenly gives a patient the wrong dose of medicine. Or think about a fire suppression system in a massive data center suddenly going off for no reason, destroying millions of dollars of equipment. Or something as simple as an elevator controller glitching out, trapping people inside. This isn't science fiction, folks. These are the real, understood risks that come with space weather. Now, beyond these immediate safety dangers, there's another huge, often hidden cost. It's the cost of pure confusion, of teams of people trying to solve a problem when they don't even know what the real cause is. It's like they're chasing ghosts in the machine. And this is where it gets so incredibly frustrating for the people on the ground. An IT manager sees a server that keeps crashing. What's the logical conclusion? The hardware must be bad, right? A technician sees a dozen different alarms going off on unrelated systems and tries to fix each one individually, but the reality is a single space weather event could be the one thing tying it all together. And that means companies waste an unbelievable amount of time and money replacing perfectly good hardware, all because they're treating the symptoms, not the actual root cause. So what is it that makes this threat so different from, say, a normal equipment failure? Why is space weather considered such a uniquely modern and tricky danger? It really all comes down to one key characteristic. This right here is the absolute game changer. Unlike a local power outage or a software bug that's contained to one network, a big space weather event doesn't care about firewalls, it doesn't care about physical distance. It can cause glitches in a hospital in one state, a data center in another, and a factory hundreds of miles away, all at the exact same time. It's that ability to cause widespread, simultaneous, and seemingly unrelated failures that makes it so incredibly disruptive. So we've seen it all now, how one tiny particle can kick off a massive cascade of failures, from our medical devices all the way to our critical infrastructure. We've seen the insane cost of just trying to figure out what's going on. It really lays bare just how fragile this interconnected electronic world we've built really is. Which, of course, leads us to the most important question of all. What in the world can we do to protect these systems? Well, that's what we're going to tackle in our final part of this series.